Hi, class. In this lecture, we want to continue talking in our study of statistics by moving into what we call measures of dispersion. So what measures of central tendency tried to do was to describe what a typical data value looks like. Measures of dispersion, what they attempt to do is describe or tell us or how spread out or how dispersed the values are in a data set. All right, so in this lecture, we have two objectives. We want to determine the range of a data set. That's really easy. And if you think about it, actually, in the previous lecture, we talked about something called the mid-range. So the range of a data set, a little bit different, is actually even easier to calculate. And then the second thing we want to talk about is how you determine the standard, what we call the standard deviation from a data set. Now, I'm going to show you how to do this by hand, the standard deviation. It can be a little confusing. And then what I'm going to do is show you how to use your graphing calculator as well to easily find the standard deviation. Okay, so first off, what is the range? So the range is used to describe the spread of data items in a data set. So the two most common measures of dispersion here are the range and the standard deviation. So the range, all the ranges is the difference between the highest and lowest data values in a data set. So literally the range you just take is equal to, you take the highest data value and subtract away the lowest data. So like, let's just pretend you have some data here, and it's someplace in Hawaii, um, Honolulu. So Honolulu's hottest day is 89 degrees, and its coldest day is 61 degrees. So the range in the temperature is just the highest value, 89, minus the lowest value, 61, where the range of data values is 28 degrees. Let's talk about this one here. We'll use this data set actually as well to do the standard deviation. So the figure here in the right shows the age of the four oldest US presidents at the start of their first term. So it was Donald Trump, Ronald Reagan, Harrison, and Buchanan. Okay, this is their age when they first got elected. All right, so let's find the age range of the four oldest presidents. Well, it's the highest value, which is Trump's age of 70, minus the lowest value, Buchanan of 65. So 70 minus 65, the range of this simple data set here is just 5. Okay, now the range is very easy. But now I want to talk about how you find the standard deviation. Okay, and what the standard deviation, this will help. Okay, the standard deviation tells us the average deviation the data values are from the mean. So on average, how far are data values from the mean or the center of the data set? All right. So let's find the deviations for the mean of the 5 data items. So I have these 5 data items, 70, 69, 68, and 65. So now forgive me, I apologize. There's only 4 data items here, not 5. So forgive that typo. All right, so the first thing you're going to do is you're going to calculate the mean. So if you take these 4 data items, 70, 69, 68, 65, and add them up, all right, you get 272, divide that by 4. So it looks like the average age of these 4 presidents here was 68 years old. All right, now what is a deviation? A deviation is you take the data item and you subtract away the mean. Okay, like Trump's age of 70. 70 minus the average age of 68 is 2. So what we're saying is Trump's deviation from the mean, all right, was 2. He was 2 years away from the average. Take Reagan's 69 years, 69 minus the mean, 68, you get 1. So he's 1 year. Harrison here, his age was 68. 68 minus the average, 68 is 0. So his deviation from the mean was 0. And Buchanan, he was 65 when he first got elected. 65 minus 68, well, he was minus 3. He was 3 years younger than the mean. All right, so let's talk about computing the standard deviation for a data set. Okay, this is the formula here, so let me walk you through how we get it. First thing you're going to do is you're going to find the mean of the data items, the average. Then you're going to find the deviation of each item from the mean. So you're going to subtract the data values minus the mean. The next thing we're going to do, I know this seems weird, is we're going to square each data item. The reason we square is if you look at the numbers 2, 1, 0, and minus 3, if you were to add all these up, they would actually sum up to 0. Like 2 plus 1 is 3, plus 0 is 3, minus 3 is 0. So that's not really useful, the number 0. So we square them to make them positive. Then we sum up. the deviation squared, so the values we just found. Then you divide that sum that you just found in step 4 by n minus 1. So n represents the number of data items. So if there's 4 data items, 4 minus 1, you would divide by 3. Now, because we squared every item, what we do is we take the square root of it to unsquare it. So with the value we just found in step 5, we take the square root of that value, and that is equal to the standard deviation. So we let the letter S equal standard deviation. So standard deviation S is equal to the square root of the sum of each data value minus the mean squared, all of that divided by n minus 1. All right, so let's find the standard deviation of the ages of these 4 presidents. Okay, so step 1, we found the mean age, it was 68. Step 2 is you find the deviation of each data item from the mean. Okay, so this was done in this previous slide here. We already found the deviation. The next thing you're going to do is you're going to square the deviation. All right, so step 3. So the deviation of 2, square it, you get 4. Deviation of 1, square it, you get 1. 0 squared is 0. Now when you square minus 3 times minus 3 gets you 9. So after you do that in step 3, okay, we've squared each data value. Step 4 is you sum the data item minus the mean squared that you just found. So the 4th step here is you take these values, these 4, this 1, the 0, and the 9, and you sum them up and you get 14. Step 5 tells us to divide the sum that we just found by n minus 1, where n represents the number of data items, which is 4. So we take that 14 divided by 4 minus 1. All right, so 14 divided by 3 gets me 4.67. Now the last thing, so what you actually just found is you actually just found the average deviation squared. So the next thing you do in step 6 is the standard deviation is the square root of this value you just found. So the standard deviation is the square root of 4.67, which is roughly 2.16. And that's how you find the standard deviation by hand. All right, it's a little confusing, all right? So let me show you an easier way to do this in your calculator. So you're going to load up your calculator, and what you're going to want to do is you're going to want to input the data values 70, 69, 68, and 65. So you're going to hit the Stat button. Under number 1, you want to edit a list. You want to input data. You'll put in the president's ages, 70, 69, 68, 65, and make sure you do this correctly. So I've got the data values 70, 69, 68, 65. The next thing you're going to do is you're going to hit the Stat button again. And you want to scroll over to Calc. You actually want number 1, which is 1 var stats. So I'm going to click on that. And I'm just going to hit Enter again. If you have a TI-84 or higher, you're going to see a bunch of options. Just scroll down to where it says Calculate and then hit Enter. And you should see something like this. Well, you'll notice X bar, the first thing, X bar is the mean. So yeah, the mean age of these presidents was 68. That's amazing. I have that right there. So it also gives me the mean. Then if you look down here, you see this thing called S sub X. What that means is it's the standard deviation of the X variable. So the standard deviation of the president's ages. Well, we did it by hand. We got 2.16, and that's exactly what our calculator shows. Just as a other preview, if you scroll down a little bit more here, you see this thing called MED. This stands for the median of the data set. So look at that. The median of this data set is telling me is 68.5 years. So this also tells you the median. So much easier to use your calculator to find the standard deviation right here. S sub X, 2.16. All right, thanks you, class.